liquids, right? And we have liquids and bottles. And we manipulated them, right? We shook them, we tipped them over, we tried to make tornadoes with them. We did so many investigations to see how liquids and how different liquids were different, how you could compare them, right? What similarities they have, but also how you can contrast them and how they are different. So remember, right? Some liquids move around really fast, so they have a lower viscosity. They're not as thick, while other liquids move slower, right? That means they're more viscous and they have a higher viscosity. Well, now, just how we tested our liquids, we are going to be testing and investigating solids in bottles. So this, I'm going to show you what I have. I have brown pinto beans. I have cornmeal. That's that yellow powder that you had in your box. I have rice. And I have a container of cranberries. So what we're going to do, we're just going to watch. I'm going to put these different bottles and containers through an assortment of tasks. And so we're going to see what happens. So first, I'm going to start by shaking all of the bottles, right? So this is the cranberries. What do you notice? All right. Now let's go with the pinto beans. All right. Listen to the sound, the volume of how loud they are when you shake them. All right. Pinto beans, cranberries. All right. Now we're going to go with the cornmeal. Do you even hear anything? Cornmeal, pinto beans. All right, and now we're going to do rice. All right. So we've shook them. Now let's compare both of them. So I'm going to shake both at the same time. So you have rice and cornmeal. All right. Let's do cranberries and pinto beans. Pinto beans, cranberries. Pinto beans, cranberries! So what's similar about all four bottles? Do some bottles have something in common where some of them are different? What do you notice about the different volumes, how loud they are when you shake them? Because when I shake the pinto beans, kind of loud, it kind of hurts my ears, but then when I shake the cornmeal, it's like a cat is tiptoeing. The cat is tiptoeing. He's walking on his paws. It's so quiet, but it's so loud. So what else do you notice? And think about, why is the cornmeal, when I shake it, a lot softer than the pinto beans? What is affecting the differences in the pitch and the volume? All right, so now what we're going to do is I'm going to tip them over. I want you to notice how they move when I slowly tip them over. All right, so I have the pinto beans. I'm tipping the pinto beans over. Notice the sound and how they move. They all clump together. Do they move individually? All right. So now let's do the rice. Do they move together? Individually? All right, what do you notice when I tip the rice over? All right, now let's do the cranberries. I do like a good cranberry. How many of you are fans of cranberries? Mr. Bergman likes them. All right, now we're going to do the cornmeal. Is it moving together? All right. So we've tested all four. Now let's compare them together. All right, here we go. All right. Do they move the same way? Do they move differently? What do you notice? And let's do the cranberries versus the rice. Now there's one thing I want to bring your attention to, and I want to talk about level, right? If we say something is level, we mean that it is flat across. Now if we look, I'm going to bring back a bottle or liquid of water, right? Do you notice how there is a flat liquid level? when we have liquids in the bottles, because liquids move and their shapes can change, right? The liquids take the shape of whatever container they are in. So whenever, right, so now the shape is changing, but whenever you have it upright, liquids will always be level, meaning there's a flat line on top where it is straight across. So now that we know what level is with liquids, let's see, do solids always come back level? Because when we move water around, it's always going to be level. No matter what we do to it, when we put it upright, it's going to be level. So when I shake this rice, is it level? Is it flat? I don't know about this one. This rice kind of looks a little slanted. Let's do the pinto beans. This pinto beans are going to be level. Is it flat? You tell me. Alright, now let's do cranberries. Move it, I'm going to tip it. This bottle's a little dirtier. Can you see if it's level? For me, it kind of looks like there's some down here and it kind of goes up. Alright, now let's do the cornmeal. Mr. Quiet, Mr. Sneaky Cornmeal. Look at, we have cornmeal on the sides. There's some cornmeal up on the sides risen up. So why are liquids always level? Even this corn syrup is level. I tip it, and as it comes back, it's always going to be level. But yet, Mr. Cornmeal isn't level. So that's something to think about. Alright? Think about, so we have shaken and manipulated 4 solids, right? We had our cornmeal, our pinto beans, our cranberries, and our rice. And we put them through a different test. We notice the differences in the sounds they make, right? Why do they all sound different, right? We tip them over to notice how they fall and how they adapt to the containers that they are in. We also noticed, and we're trying to investigate the levels of the liquids. All right, so we're going to talk about this more in class. I'm going to give you an opportunity to do this investigation at home as well. All right, class. But thank you so much. Let's discuss.